Hi guys, this is Miss Flanagan. Today we are going to continue our energy unit by talking about phases of matter. On screen, I have included the three most popular phases of matter: solids, liquids, and gases. Take a minute to observe their differences. All matter exists in one of three forms: solids, liquids, and gases. First, we are going to talk about solids. Think about if you were to put a metal cube in a beaker. Solids have a definite shape and a definite volume. Solids change very little with changes in pressure and temperature. They are tightly packed and have slowly vibrating molecules and atoms. They do not change position. Next, we have liquids. Liquids have no definite shape, but a definite volume. Think if you pour yourself a glass of water. The water takes the shape of the container and has a horizontal surface. Pressure and temperature have a small effect on liquids. Liquid molecules move faster and are less tightly packed compared to solids, and they can change position. Lastly are gases. Gases have no definite shape and no definite volume. Molecules spread out indefinitely, and gravity has little effect on gases. However, temperature and pressure changes have a large effect on gases. Gas molecules are very spread out and move very quickly. Think about if you were to pop a balloon. Those molecules would spread out indefinitely very quickly. So why are we talking about this? Let's talk about changing phases. When you go from a solid to a liquid, that's called melting, and a liquid to a gas is called boiling. During a phase change, like melting or boiling, all the energy added does not cause a change in temperature. Boiling water stays at 100 degrees Celsius. It does not heat up. All energy added goes to change the phase. Potential energy is stored as a change of phase. Let's look at a heating curve. On my x-axis, I have time, starting at 0 on the left and increasing to the right, and I have temperature on my y-axis, starting from 0 at the bottom and increasing upward. My first slanted line represents the solid phase. As temperature increases, my solid molecules begin to gain energy. Next, I hit my first plateau, which is melting. During this time, solid molecules begin to change to liquid, and there is no temperature change, noted by the horizontal plateau. Once all my molecules change to the liquid phase, they begin to heat up, noted by your next slanted line. As temperature increases, your molecules begin to move faster. Eventually, they hit the next plateau. If we were talking about water, the melting point is 0 degrees Celsius, noted by our first plateau. And the next plateau, the second plateau, labeled boiling, will be 100 degrees Celsius. Again, this is for water. Note the plateau, which means there is no temperature change, and the liquid molecules are beginning to change to gas molecules, thus we call it boiling. Lastly, the molecules heat up once they hit that next slanted line, and they all are in the gas phase. The slanted line again represents an increase in temperature, since we were talking about a heating curve. As temperature increases, kinetic energy increases. Remember, kinetic energy is your energy of motion. Potential energy, or PE, noted on our heating curve graph, stands for potential energy and is the energy of stored. Next, we hit our plateau. Potential energy is increasing because we are storing our energy in a phase, and kinetic energy remains the same because there is no temperature change. Next, when we hit the liquid phase, kinetic energy increases again because temperature is increasing, and potential energy stays the same. When our particles begin to boil, kinetic energy remains the same because there is no temperature change, and potential energy increases. Lastly, in the gas phase, kinetic energy increases and potential energy remains the same. Again, remember, during phase changes such as melting and boiling, represented by our plateaus, kinetic energy stays the same and potential energy increases. However, during our solid, liquid, and gas phases, noted by the slant lines, kinetic energy increases because temperature is increasing and potential energy remains the same. Thanks for tuning in. Tomorrow we will discuss cooling curves.